Hello, welcome everyone to the IEA Bioenergy Webinar hosted by ETA Florence Renewable Energies. My name is Chiara Benetti and I will be kicking off today's session. Today we have the pleasure to have Dr. Jitka Herbeck, the University of Natural Resources and Life Sciences Vienna, Senior Scientist, Institute for Chemical and Energy Engineering, and Bernd Fröttenhill, TNO Energy Transition Innovation Manager, Gasification, Gas Cleaning and Upgrading, who will present on the past, present, and future for biomass gasification. The session will be moderated by Luc Peltmans, IEA Bioenergy Technical Coordinator. I will now pass over to Luc, who will begin today's session and will introduce today's speakers. Thank you.
Okay, thank you, Chiara. I hope everybody can hear me. So from my side, I also want to welcome everybody to this webinar, which is centered around biomass gasification. My name is Luc Peltmans, so as Chiara has mentioned, I'm a technical coordinator of IEA Bioenergy. IEA Bioenergy is actually an international group, and we are a technology collaboration program operating in the framework created by the International Energy Agency, the IEA. And we have a lot of members, we have a lot of work going on in our group, and our work is organized through what we call smaller networks. They're called tasks. And one of these tasks, it's task 33, it's on biomass gasification. And in this webinar today we have two of the leaders of that task, Bernd Fröttenhill from the Netherlands, from TNO Energy Transition, and Jitka Herbeck from Austria, from University of Natural Resources and Life Cycles in Vienna. Just to clarify a bit the setup, so we have around half hour for the overall presentation, and after that we have a Q&A session, a question and answer session. If you have a question, you can put them in the chat box, which you will normally see on the screen. And so after the presentations, we will go through these questions and try to answer them as much as possible. I will moderate that part. One thing I also have to say is that I think there is a voting question which will appear, I think, just after the presentation, and you are also welcome to give your opinion on that. So enjoy the webinar, and I now hand over to Bernd. I think Bernd is going to start the presentation. So please go ahead.
Thank you, Luc, and good day to everyone listening in from all over the world. I see we have about 100 people listening in. That's nice. As it states, the webinar is about the past, present, and the future of gasification, where I will be presenting a little bit on the past, what has happened, and on the future, with some concluding remarks. And Jitka Herbeck, my colleague, will tell you something about the present situation around gasification. So the goal of this webinar is to show to you the long history of gasification and the versatility of the applications that it has been used for and that it can be used for. We will also show some of the current applications and the developments that are now ongoing, and from that we will try to paint a picture what a possible future for gasification can be. And of course this last part is maybe a little bit biased by what I know. If there are questions about this or points of discussion, please join after the presentation for this bit. And I was also asked to briefly tell something about what is gasification, and that could be a webinar on its own. So I try to capture it in one slide. And basically what you do in gasification is you partially burn part of your feedstock. And you do that to the extent that the generated heat is sufficient to convert the remaining feedstock into a usable gas. So this gas is not flue gas, this is gas containing CO, hydrogen, methane. Well, it depends on the temperature, but it has an energy value. And then your gasification technologies can be divided in several ways. You can look at low temperature up to high temperature gasifiers. The temperature has a strong effect on the composition of the gas, where with low temperature you produce more complex molecules. Your conversion is also not 100%. If you go to high temperatures, you will produce mostly or only CO and hydrogen. And that's really suited for syngas applications. You can also look at how you perform the gasification, and then you have in principle 3 different technologies: fixed bed, fluid bed, and entrained flow, where the fixed bed is more that you have a stacked biomass which is slowly being converted using typically air. Fluid bed is a bed of sand particles which is fluidized with air, in which you convert your feedstock into gas by burning part of the feedstock and converting the rest. And entrained flow is really used for high temperature applications, where typically you go to very fine particles or to liquids, and then you really aim for syngas applications. Then there's also the opportunity to make the distinction in direct versus indirect gasifiers, where a direct gasifier combines the combustion and the gasification part. So the heat generated takes place in the same vessel where the gasification takes place. An indirect gasifier, as it states indirect, it's converting the energy not by directly combustion, but by transporting, for instance, using a bed material. And that has a strong effect on the quality of the gas, where the direct gasifier is diluted with the CO2 that you produce from your combustion. And if you use air, it's also further diluted from the nitrogen. And an indirect gasifier, there's no dilution with this nitrogen or CO2. So you get a more rich gas, which has other applications. And that will also become apparent, I hope, from the presentation. So if you look into the history, this table shows a little bit what has happened over the years. Pre-industrial, so before 1900, from 1900 to 2000 and until today. What you see is that really in the beginning there were some applications. There was biomass to syngas for food preservation or to produce liquids for their like tars for their chemicals, and that's all on biomass. And you see there's nothing happening with fossil fuels in that decade or in that era. Whereas from 1900 to 2000, a lot of things happened with coal gasification to produce gas or liquids or crude oil or natural gas conversion. So that's all fossil based. But you also see some additional things happening with biomass co-firing, biomass to syngas, CHP with IGCC demonstration. So there was also biomass activities, but most of it happened with fossil fuel. And then from 2000 onwards, the fossil applications, they remained, but you see also a very big growth in the CHP, the biomass CHP applications, and co-firing, and also utilizing MSW, so waste gasification, and slowly going also towards biofuels or SNG, depends on what the application is. My presentation now. So and then there are also more unusual applications with gasification. I took some from the internet. You have cars driving on wood gas or on gas from gasification. So on the back of a car or a bus, you put a gasifier. And actually in World War II, there were over 1 million of these cars driving around because there was not sufficient normal fuel that all went into the war machine. Town gas, this is a picture from the Westergasfabriek in Amsterdam. There was also a very normal application for gasification where coal was gasified to produce gas that you could use for your household heating. And the right, the picture is a kitchen application in Indonesia where a small gasifier is used to produce gas on which you can cook. So it's a very rudimentary application, but yeah, in principle, it doesn't have to be that difficult. Gasification is something that you can use in many fields. And then how did this grow? This picture, you can find it on the website of Hickman Consulting, but it shows the growth of gasification from the 1950s, and you see that it has been increasing since 2000 quite drastically, and a lot of capacity is under construction and even more in the planning, and it's expressed as megawatt thermal synthesis gas. So this is big installations. If you then look into what the feedstock for these installations is, it's mostly fossil. It's coal predominantly, and then petroleum and gas, and it's just 1% biomass in this share. So gasification is huge, but if you look into biomass, it's not that big yet. And these are some examples of the large-scale applications, which is all on fossil fuels, but it's really gigawatt scale installations. And over 100 plants installed, most of them in China, I would say. And you see it's predominantly fossil-based, but the variety of products is actually quite large. It's Fischer-Tropsch, methanol, SNG, and electricity, ammonia, hydrogen. So it's very, very diverse in the applications that it's used for. Then if you go to more small-scale applications, the picture is completely different. The output or the installed capacity is rather limited. This picture shows the installed capacity only in Germany, Switzerland, and Austria. But the interesting thing here is that the number of plants actually is quite large. You see close to 1,000 plants in total, and more than 400, I would say, in Germany. This is all small CHP applications, but it's all gasifiers that are in operation. So on a small scale, it's all proven and ready to go. It's also a good message to take home. Then the following example is based on fossil fuel. I was reading on the Dakota Gas website about the history, and I found it very interesting. And I think we can learn a lot about how they or how things went there. So in 1972, the decision was made to build this large coal gasification flagship, coal to SNG substitute or synthetic natural gas. But it still took 8 years before they finally started construction. And in the meantime, there were several occasions where the plant nearly got shut down, or that the project never started because of inflation, legislation, politics, or governments that changed, offtake contracts that were not in place or not the right prices, falling energy prices, emission limits. So there's many things that can make or break a project, but eventually they started in 1980, and in 1984 they got online for the first time. But still in 1985 they nearly had to abandon the project again because they were not making money, and the forecast was that they were going to have would lose a lot of money before they actually started making money, and then the DOE took ownership. And in 1988, Basin Electric they obtained the ownership for this plant, and they formed the Dakota Gasification Company. So that's 16 years later, where you have actually a company that is till today still running this plant. But that's how much time it takes before it can be called a success. Then if you look into what they were set out to make, the synthetic natural gas, to become independent from external energy suppliers. In 1984, they started up the plant, and they also started producing anhydrous ammonia and sulfur. And you can see the list over the years. They added different products like light oils and phenol, krypton, xenon, and cryolic acid, fertilizer, until 2017, so just 3 years ago, diesel exhaust fuel fluid as a product from this plant in order to improve the business case. So it's interesting to see that a plant that is started as a gasification plant for SNG production over the years develops more or less into a big refinery plant. So what can we learn from this is that, well, gasification has been around for centuries. I think it's not a new technology in that sense. And it also has been successfully applied for different feedstocks, and also to produce different kind of products. Some were temporary because of, well, wartime, but some of them still out there today. And the early applications, I found that even more interesting, were actually high-value products. The chemicals and the food preservatives today would be a high-end product. It's also good to notice that the percentage of installed capacity for biomass gasification is small compared to fossil. That's not a big surprise, but the number is quite large. Only for the 3 countries mentioned, it's close to 1,000, and then there's even more in India and China. So the numbers are quite large. Gasification also shows the opportunity to develop from one single product to more like a refinery approach. Maybe not for all gasification technologies, but at least for some technologies. And it's also flexible towards the desired output. So if you produce a gas containing energy in the form of CO and hydrogen, you can choose to go to a boiler or to an engine, but you can also try to develop projects towards biofuels or towards chemicals. So it's very diverse. And then the next part is Jitka. She will take over now.
Hello, my name is Jitka Hrbek. I'm from University in Vienna. It is University of Natural Resources and Life Sciences, and I would like to start my presentation on the current status of gasification. The content of my presentation, at the beginning, I would like to say some words about the status of thermal gasification. Then I would like to talk about the countries which were the member countries of our task in last triennium. Then overview and description of some reference facilities, and at the beginning, I would like to conclude the actual status. In Austria, at the moment, in comparison with the past time, there is a boom of small-scale gasification facilities. At the moment, we have 5 producers of small-scale facilities. It's Urbas, Simkraft, Glock, Ecoenergie, Hargassen, and Fröhling. All these facilities are fixed bed. Just Simkraft produces floating fixed bed gasifiers and focuses also on biochar production. Contrary to this boom in small-scale gasification, all large-scale facilities in Austria are now on hold. For example, Güssing, the construction of this demonstration plant started already in July 2000, and it was in operation from November 2001 to October 2016. With this demonstration plant, the scale-up of fast internal circulating fluidized bed gasification process was realized and at the first time. Therefore, the plant in Güssing can be seen as a reference plant for other facilities based on this technology. These plants are in Germany, in Senden, in Sweden, in Göteborg, and in France. It is a Gaia project. At that time, when Güssing was operational, due to favorable characteristics of the product gas, there were several research projects ongoing. There was a used slipstream, and the focus of the projects were on production of Fischer-Tropsch diesel, production of SNG. It was also a topic solid oxide fuels from the gas and catalytic cracking of the tar. It should be said that after almost 100,000 operating hours, the biomass gasification plant was shut down at the end of October 2016 due to economic reasons. The situation in Austria is so that renewable electricity production is supported by feed-in tariffs, and these tariffs are for 13 years. And this feed-in tariff finished in October 2016, and without this tariff is no economic operation possible. That's why the Güssinger plant was closed down. Now the research and development in Austria focuses on waste materials feedstock, characterization of and usage, and also on applications of product gas. And next year, waste gasification facility near Vienna should be built, as you can see on this picture. It should be 1 megawatt double fluidized bed gasifier with 300 kilowatt Fischer-Tropsch synthesis pilot plant. It will be built near Vienna in Simmeringer Heide, and also a research lab will be included in this plant. Here will be the focus mixed alcohols and hydrogen separation. Next country I would like to present today is Denmark. At the moment, there are 3 big plants in operation. One is in Harbore, in Sindal, and in Skive. All these facilities focusing on combined heat and power production. Their fixed bed is in Harbore, stage updraft is in Sindal, and bubbling fluidized bed in Skive. I would like to say some words about the Skive plant. In Skive, commissioning started already in 2007 using just 1 gas engine, and operation began in summer 2008, and after that also 3 further gas engines were installed. As you can see in the picture, it is a bubbling fluidized gasifier with woody biomass input 20 megawatt as a feedstock. It has 3 engines now and produces heat about more than 1 megawatt. Thermal district heating is it produces district heating, and electricity is sold to the grid. It should be mentioned also the public funding. It came from Danish Energy Agency and European Commission and US Department of Energy. It should be mentioned that after several years of intermittent operation, the plant has now reached high availability. And Skive Fjernvärme, who is the owner of the plant, has been looking into the opportunity to utilize the gas not just for heat and power production, but also the production of gasoline and other products. The next slide is about 3 plants which are not already in operation. It's a Pioneer plant, Viking gasifier, and a plant in Hillerød. All 3 plants are now on hold or mothballed. Pioneer plant, it was circulating fluidized bed gasifier with 6 megawatt thermal. Commissioning was in 2011, and feedstock was straw and manure fibers. The gas was co-fired in coal-fired unit. and it was planned also the upscaling up to 60 megawatt thermal, but this technology was not as successful as supposed, and it was not sold. 2015 it was mothballed, and now it is as a research facility at DTU. Viking gasifier, it is stage gasifier with 500 kilowatt electric. It is for district heating. It was just a few times in operation, and it was dismantled in 2016. But this plant, as the pioneer plant, is still as a research plant at DTU. And the third plant is a stage-down draft gasifier, which was developed and patented by DTU. Anyway, also this is now dismantled, which was in 2018. In Germany, the situation is, I would like to, at the beginning, talk about large-scale facilities and then to come to smaller ones. Biolik pilot plant, I think almost of you know already Biolik. It's this plant. It is decentralized part where the fast pyrolysis takes place, and the biomass, mostly it is straw, is processed to biosyn crude, and this biosyn crude is in a centralized part, gasified with entrained flow gasifier. Then after gas filtration, gas cleaning and conditioning, DME and gasoline type products are produced. As I said, the product is DME. It's about 608 tons per year. In operation is the plant since 2010, and DME and gasoline synthesis since 2014. The plant is technical readiness level 6, and they use this plant for research. They have mostly 1 or 2 campaigns per year where they are testing different types of fuels, and I think the results you can find at our website, in what I can show you later. The second one is Blue Energy wood in Senden. Also, this plant is now on hold. It was operational till 2018. It was operational by Senden company, and now it was bought by Blue Energy Wood, and the operation was not anymore, so it was complicated, and it was from the commercial side of view, it was not really possible to operate further, and now the plant is on hold. And about other gasifiers in Germany, there are also entrained flow gasifiers producers, fluidized bed gasifiers, and fixed bed gasifiers. So as I already talked about Biolik project, Ehrlich entrained flow gasifiers was also involved in by Biolik project. There is also ThyssenKrupp Industrial Solutions, and by fluidized bed gasifiers is Sulzekov, Burkhardt und Stadtwerke Rosenheim. And from fixed bed gasifiers, so I think you will know the company Spanner, Regavat or Lipro, and also Biotech Energietechnike MPH. In Italy, the situation in Italy, it is the really boom of small-scale gasification. As you can see in the table, there is at the moment, more than 218 plants in operation. Most of them are situated in northern Germany, and they produce more than 43,000 kilowatt electric. And as you look at the size of the plant, the smallest one are more than 60, so about 70. It is between 20 and 70 kilowatt electric. And just few plants are with output about 800 to 10,000 kilowatt electric. In Italy, there are at the moment 3 producers of small-scale gasifiers. CMD, downdraft gasifier, output about 20 kilowatt electric and 40 kilowatt thermic. ESPE, they produce also small-scale gasifiers with output 49 kilowatt and 110 kilowatt thermal. And Reset, they produce fully automatic plants with output between 50 and 200 kilowatt electric. They produce also a high-grade biochar, which they sell to the market. In the Netherlands, I would like to talk about Bioenergy Netherlands. They produce modular plants for combined heat production. But in the future, they would like to also focus on other products like biogas and hydrogen. Then it's Bioenergy Netherlands uses modular plants, and because of this modular structure, they can focus on different applications. The gasification plants of Ben use biomass mainly in form of residual wood. In November 2017, the construction of wood gasification plants started in Port of Amsterdam. The technology is supplied by 0 Point Cleartech, which is fixed bed technology. And the first phase is expected to be operational in May, was expected to be operational in May last year, so I think now should it be in operation. There is also a collaboration with Jenbacher, with gas engine producer, and the plant in Amsterdam is designed for a total of 15 megawatt hours of combined heat and power. Essent owns and operates a waste wood gasifier connected to a 600 kilowatt coal-fired power station. The plant is situated in Geertruidenberg and is called AMER 9. The coal plant co-fires biomass in 2 different ways. Approximately 25% of energy of clean wood pellets are dielectric co-fired, and another 5% are indirectly co-fired through a gasifier. The gasifier was built in 2000-2001 and did undergo several hardware modifications, which were related to fuel feeding and gas cooling and cleaning. The capacity of gasifier amounts 85 megawatt hours, and it is near atmospheric circulation fluidized bed reactor, which is based on low-G technology. SK is the leading global manufacturer of recovered paper-based substrates for a wide variety of industrial applications, including hardcover books, luxury packagings, puzzles, and so on. I think you know SK already. SK uses gasification to replace natural gas. SK uses circulating fluidized bed technology to gasify paper rejects and using the product gas as a feed to a boiler. The technology was implemented in 2016, and the installation is a 12 megawatt thermal circulation fluidized bed boiler processing 25 kiloton per year of reject to produce steam for the on-site processes. The plant started operation in 2016. And also ECN, which is part of TNO, this is a company of Berend. ECN has developed a technical route to convert biomass. This technology is based on Milena indirect gasifier combined with gas cleaning Orga system. So maybe Berend can say you some words more about that. Mavitech, they produce a turnkey technology. They are focusing on downdraft, fixed bed. Feedstock are different manures and sludges and other difficult materials. They produce gas, which is directly combusted after a gasifier to produce heat. And they produce also ecochar, which is sold to the market. Sinova is a new Dutch company. They are a company in the field of waste to energy. They develop standardized modularized unit-based system based on Milena and Olga, as I already talked about. And they are planning to build a plant in Thailand. And Sinvalor developed a new multi-stage vortex reactor for the gasification of all kinds of fuels, but they are specialized on the difficult fuels. It aims producing of low-tar produced gas for gas engines, and the goal is to keep the investment below 2,500 euro per kilowatt electric. Currently, they are commissioning a gasifier for Gebra Grower, and results are expected. Torgas is a company which was founded in 2012 and specializes in the development of biomass to energy and biomass to chemicals projects. The objective of Torgas is to develop a technically and commercially prove the operation of biomass gasification process to produce chemically grade syngas, which is free of nitrogen and tar. And this, with these boundary conditions, they would like to have a process which is scalable, which is financially feasible and easy to operate, and it is, of course, reliable. The next one is SCW. It's a young company focusing on supercritical water gasification. Our first demonstration plant it was constructed in Alkmaar and started in second half of 2018. This technology is different from the others I already described, since it goes to very high pressure and high temperature. Typical operating conditions are more than 220 bar and high temperature. And under these conditions, water changes into supercritical phase and salt will crystallize with organic materials and they will dissolve. This solid can be taken out of the supercritical phase, and the dissolved components can be react to produce methane, hydrogen, and CO. And the host, the expertise of the host focuses on the technological development of the processing of biomass and waste streams, and the supply of systems for renewable energy from biomass and waste. Host offers now a range of technologies from anaerobic digestion and biogas upgrading to biomass combined heat and power plants and boilers. In their range, they offer also CFP gasification technology for boiler applications. And now let's go to Norway. In Norway, there is a small-scale gasification from company Volta, which started already in 2016. But it should be pointed out that in Norway, the prices of energy are relatively low. They have a lot of hydropower in Norway. That's why the combined heat and power production based on gasification of biomass is too expensive for them in comparison with other energy sources. Anyway, on this place, these two projects should be mentioned. Quantafuel. Quantafuel is a plant, which is in Skive and which focus on Skive is in Denmark. Anyway, it is a Norwegian project, and this plant focuses on conversion of plastics from local suppliers and produce local, environmentally friendly, high-quality fuel. They would like to convert approximately 18,000 tons of plastic per year, and output should be more than 15 million of high-quality recycled fuels. And the second project is biofuel, which focuses on sustainable economic products of aviation biofuels from household waste. And the projects in Sweden. In Sweden, there are not really small-scale gasifiers. There is just one of them, which is in Diary. It is the only example and has an output of 40 kilowatt electric and 100 thermal. And now about large scale, I would like to talk about Go by Gas project and also LTU Green Fuels AB. Go by Gas, I have on a separate slide. It should be said that the Go by Gas was planned as a two-phase project. Gothenburg Biomass Gasification project has been Gothenburg Energy's largest investment in biogas production and the first investment outside of conventional biogas products plant. The aim of the project was to supplement conventional biogas production through gasification of solid biofuels and forestry waste. They reviewed a technology, and after revision of technology, the status was showing that at the moment there was no similar plant operating on this technology, which was validated in large scale. That was the reason why the project was split into two phases to reduce the technical risks. And the first demonstration plant was 20 megawatt product gas, and it should be followed by the second phase of 80 to 100 megawatt of SNG, of biomethane. However, it should be pointed out that the first phase is not operational at the moment, but it was also never intended as self-sustaining project. It was only the context of also going forward on phase 2 to reach 100 megawatt gas. Official startup of the first phase was in October 2013, and the plant was in operation till May 2018. They had more than 1,800 operation hours. And the reason why the plant was shut down was that the sales value of biomethane hadn't followed the projections. It should be said that biogas was imported from Denmark, where the importers get the money for that, and it was not really available to operate the plant further. The next project I would like to talk is the Cortus Energy. Cortus Energy is a company which develops the wood roll technology. What can you see on this slide? It is a stage technology. It integrates 3 stages: is a drying, pyrolysis, and gasification. And it has been reported that the gasifier has been operating over 5,000 hours in September 2018. and the dry and pyrolyzer over 2,000 hours each. I'm sorry. In late 2018, Cortus was also awarded a grant from Swedish Sustainable Aviation Fuel Program, and at the moment they cooperate also with Japan and other countries. MEVA is the owner of VIPP technology, which originates from developments by LTU. A test unit was installed at ETC in Pitea. It was already in 1990s. The purpose was to develop a small-scale combined heat and power system based on small-scale gas turbines. But in 2008, MEVA Innovation changed name to bioenergy AB and acquired the rights for the cyclone gasification technology. The gasifier is fed with pulverized fuel, and the gasification agent is air. And the cyclone is operated between 8 and 900 degrees. Switzerland, the situation in Switzerland is similar as in Italy. Anyway, the boom of small scale cannot be seen here. There are just 7 operational plants at the moment. All of them are fixed bed gasifiers. These fixed bed gasifiers are mostly produced by Volta, Regavat, Burkhardt, Ligento, Vekshach, Panna, and there are also 2 units from Pyroforce. They are aiming to produce combined heat and power, and also the heat is used for district heating. And the last country I would like to talk is USA. In the USA, I would like to mention 3 projects. It is necessary to say that in the USA there are almost no small-scale gasifiers at the moment, but they are focusing in USA on aviation, biofuels, and liquid fuels from gasification at all. I would start with red rock biofuels. The feedstock of this process is a mixture of softwood and forestry waste materials and some pre-commercial signings. The feedstock will be obtained from non-federal land in southern Oregon and northern California. 70% of annual feedstock requirements is under long-term contracts, what is really good for that. Conversion to biofuels is in this case a multi-step process involving feed receiving and processing, gasification and syngas cleanup, catalytic conversion to Fischer-Tropsch products, upgrading fuel, and fuel distribution. The biomass gasification technology is a steam reforming process, license from TCG Global, and syngas cleanup and conditioning, including tar reformer, is designed by company Fluor. Red Rock Biofuels broke ground on the Lakeview facility in July 2018, and the plant is currently under construction. Completion is expected in mid-2020, and operation should start maybe this year, but maybe also next year. It is not really clear. The next one is LanzaTech. LanzaTech, they would like to build a new biofuels production facility which will produce about 60 million gallons per year of ethanol. The plant will be located in California, or roughly about 150 kilometers from San Francisco. Biomass should be converted to syngas through gasification using a plasma-enhanced melter technology. and syngas from the gasifier will be fed to LanzaTech microbial fermentation technology to produce primarily ethanol. Construction is scheduled to start in 2020. And Fulcrum Bioenergy Sierra Biofuels plant near Reno in Nevada should convert approximately 200,000 tons per year of municipal solid waste into 10 million gallons of renewable synthetic crude oil through feedstock preprocessing, gasification, and Fischer-Tropsch synthesis. The gasification technology is indirectly heating fluidized bed steam reformer. There is a link if you need some more information. And this is our website. I would like to show you where you can find our project. In the middle of the site you can find past 33 projects, and one of these projects is status report on thermal gasification of biomass and waste, which was finished in 2019. More information, which I forgot to say today, you can find there in this report. This report is based on information from our member country representatives and also is based on our database, which is a part of our site. And to summarize this current status, I would like to say that the boom of small-scale gasification for combined and heat power applications can be observed in Europe during the 5 past years. At the moment, we have more than 1,500 operational units, but anyway, in the database, you are not able to find them all. We have in the database just reference plants. The second thing I would like to say that large-scale gasification facilities are now mostly closed for economic reason. It is not a technical reason. Feedstock for gasification moves from clean wood, as it was in the past, to waste and other difficult materials. And synthesis gas from gasification can be used in different ways. For example, for biofuel production, Fischer-Tropsch kerosene is one good way, and the second is SNG production. And very, very good is also a combination of thermal gasification with other technologies, for example, wind power and photovoltaic, which offers a new possibilities. I should point out that bioenergy is one of the essential sources for energy supply in our world without fossils. So, and this is everything from my side, from this presentation, and now Berend will take over.
Thank you, Jitka. Yes, the future of gasification will be slightly more difficult to predict, but still it's nice to think about it. If you look into some of the strategic research and innovation agendas, for instance by ERA or IEA Bioenergy, there you see that bioenergy in general, but also the role of gasification is underpinned by their reports. It's important in order to reach the goals that are set out by the EU. And I think that with the Green Deal that Ursula von der Leyen has signed for the EU, especially advanced biofuels will become very necessary in order to meet our targets, and their gasification will be one of the key technologies. So the future is in this area, but there's more developments that are on their way. There has been some reports in the last triennium of the IEA Task 33 on how gasification could be used, the gasification of waste for energy carriers, but also implementing CCS or bio-CCS in biofuel production or producing hydrogen from biomass gasification. And what you see is that, for instance, in waste management, typically in Western Europe, Most of it is incinerated. In Eastern Europe, there's more going into landfill, and in, for instance, Asian countries or developing countries, even more is going into landfill or just, well, ending up into the ocean. And there you see that gasification offers the possibility not only to produce heat and power from the feedstock, but also develop routes where you start working on recovery of chemicals, so the building blocks of the original plastics. The biofuel production with CCS is an important one because that actually helps you to become to reach negative CO2 emissions. You do need places to store the CO2 in that case, but this, for instance, is already being done with enhanced oil recovery, like the Dakota plant is doing. The hydrogen production is an interesting topic because if you look in how sustainable hydrogen is produced to date, or the price at which it is produced, then gasification can easily compete with that. Not compared to fossil fuel, but at least it's a good case. And two other topics for which I prepared some slides is also the refinery integration or the steel industry, where gasification also can play an important role in becoming CO2 neutral or more bio-based. If you look into refinery application, Chalmers University, last year they made a nice overview on this, on how a refinery could become more sustainable. At TNO, we've looked into gasification of more plastic-containing waste streams. So what I plotted here is the gas composition of a typical biomass gasification test, and what you can see there is that your main components on a volume basis are hydrogen, CO, and CO2. Over 75% is these molecules, and then hydrocarbons is the remaining 25. Whereas if you start gasifying waste streams, plastic waste streams, you see that the amount of hydrogen, CO, and CO2 becomes less than 25 on a volume, and on a mass or energy balance, it's even smaller. And you start to produce methane and ethylene, propylene, benzene, and these components or this gas composition actually starts to resemble the outlet of a naphtha cracker. So there you see that gasification is a technology that can unlock a huge potential of waste streams and start working on what's called the circular economy. Then if you look into the steel industry, it was mentioned before, the Cortes wood roll technology. What is happening in Sweden there at Höganäs AB, they erected a gasifier 14 meters high, and that's used to produce a gas from forest residues, replacing natural gas in the steel process. And there you just have the gas coming out of the gasifier, so that's containing CO, hydrogen, CO2, but you could also work towards producing hydrogen from this gas and use hydrogen directly in your steel making process. So there's several applications for a gasifier to be used in this industry, and there are other industries which are also very energy intensive and relying heavily on fossil fuels, where gasification can play an important role. And that's also with the current the realization that our environment is not heading in the right direction. The options for gasification are becoming increasingly interesting. So how will this develop? I think that first the biggest development will be gasification of biomass to produce biofuels. There are several examples. I just put a few here, also to highlight different technologies and different outputs, because the Biofuel project in France is using entrained flow gasification, high temperature, producing Fischer-Tropsch and making from that aviation fuel or diesel. Engie has a development ongoing in France also, where they go for renewable natural gas or substitute natural gas using a dual fluidized bed gasifier. Sungas Renewables from the US is a spin out of GTI, and they focus on producing renewable natural gas. And Enerchem is looking more into waste gasification, so that's a mix of biomass and plastic, household waste, and converting that into methanol in a bubbling fluidized bed. So it's different gasification technologies, different biofuels, and these developments are ongoing, and it's not the only developments that are ongoing, but this is really happening, I think, because of the changing perception on where should our fuels come from. Replacing fossil fuels in industry, that was the other option, is replacing natural gas as a heat source with a biogas. Producing hydrogen, I think that's an interesting one, and there is an example I found on the internet. There's not so much available on that, but it's RWE using Furek technology to produce hydrogen. That's what you find on the internet. But again, gasification technology to produce an energy source. Then, well, what I find a very interesting one is the link between waste which contains plastic and use that in a gasifier to make new building blocks for plastic. So basically cracking this feedstock into a gas that can be used to make new plastics. That's a development that you see, so in the refinery applications, and also co-production schemes. So companies are not focusing on one product anymore. They are looking into ways of producing more. And there's some examples like Mavitec and Torgas. They have a co-product, and Syncraft as well, where they can co-produce biochar, which is helping also to make the business case work. And Sinova, they have the opportunity to produce BTX from the gas before they use it in an engine. So it's not one product anymore. It's more, and you do that in order to improve the business case. And I think these are the ways where gasification will start to play an important role. And I think the biofuels route will be one of the biggest developments in the ongoing years. So the conclusions that I would like to make is that the biggest possibility, in my opinion, is for biofuels, and not to grow in numbers like with CHP, but actually to achieve growth in scale. Co-production, I think, is very important in developing sound business cases. I like the Dakota Gasification Company example, where you see that this is a natural process. Not every gasification technology is suitable for this, but when your technology is, then it's something to keep in mind. And gasification holds the key in unlocking the combination of the bio-based economy and a circular economy, because in a future energy system where fossil fuels are phased out and waste streams are reused more and more, there will be a loss always. And if you want to avoid supplementing the loss with fossil fuel, you will have to look into biomass. And then gasification is one of the technologies that can unlock this potential as well. And in that sense, it's a combination of both these economies. And then I would like to end with a warning, because over the years many projects have failed, and I think not so much because of technical reasons, but mostly because of financial reasons. I think the Go by Gas is a very good example, where they build a demonstration plant, and then at a certain point they expect this demonstration to be commercially viable, which was never the case, and then, well, they pull the plug. But gasification has so much potential. That's what we've tried to show, that it can be applied in many fields of industry. This raises the expectation of the technology, but and that also sometimes make people forget that the development pathways is not always an easy one and not always a cheap one. I think there's a mismatch. This mismatch has led to good projects being stopped, not so much for the technical reasons, but mostly financial reasons. That at a certain point, it's just too expensive. The quota plant was almost stopped several times because of financial reasons. Gasification has the flexibility to change over time from one application to another. You can see this as a strength, but you also have to be careful because it's also a weakness. It can affect your credibility, changing from one application to another. You can say we make today we make SNG and tomorrow we make methanol because syngas is syngas, but that also comes with a cost. So it's possible, yes, but it's something which will cost you money, and that's something you have to keep in mind. So with these warnings, I would like to end, and I think we're over time, and Luc will take it over now.
Okay, thank you, Berend. Yeah, indeed, it took a little bit longer than I expected. So we're already over the hour. I think we can open it up for the questions. So we had quite an intensive use of the chat box already. Most of the questions were for clarification, I think, and some of them, well, most of them actually, have already been answered. I see now that there are more general questions popping up, so let's go through them. So meanwhile, you can also see the poll, which is there, should be on the left of your screen. It also links to what to Berend's one of his final slides of the different applications of gasification and what products or what materials can be made out of it. And so the question is, what would your expectation be of gasification towards the end application? So that would be interesting for us to see how this comes out. Okay, I suggest that we go to the questions now. I'll have to go through them from the beginning, just in case that we haven't touched some of them. So some were for clarification. Let's see, some questions on Bioleak. There's a question here on tar sampling and analysis for gasification. Somebody, so Fozia El Abdelawi, said, well, the last certificates or the last sample data found was from 2006. You know why? Has there been work afterwards, or I'm not sure if you know more about that.
To my understanding, is that this was part of a EU project where the tar sampling protocol was developed and became a SEN standard. And I don't know. I don't think there has been any development after this time. So this is what it is. 2006 is also the year that I started working in this field. So.
Okay.
I don't know anything from before this so much.
All right, but I guess there's still analysis going on in sampling.
Yeah, and people use the norm for tar sampling indeed.
Yeah. Okay. Another question here was why certain projects like in Weiss and Viking being closed. I think that were the ones in Denmark. Is that also related to your last slide that you said, well, it's more for economic reasons than for technical?
Yeah, I don't know the specific for the Viking plant in Weiss, but yeah, my perception is that a lot of the projects are stopped because at a certain point it's not economically viable anymore. I think the Gusing gasifier is an example of this, where after the subsidy ended in the plant finally just stopped operating, but it ran, I think, 13 years with a fantastic track record, with a lot of additional work being done with regards to biofuel production. But at that point it was not economically anymore, and then they stopped, which is a pity, of course. But
yes, it's most of the reason is the economical point of view. So technology works well, and it is possible to make it operational for more than a year. But because of the economic situation, the most of these facilities stopped down.
Okay, thank you. I'm scrolling further to other questions that there were. There was one question, Francois Beaufrère. He said, "Well, I'm looking for a 10 kilowatt electric portable gasifier for domestic applications. Do you know if that's existing in that small scale?"
So I know a company in Austria. The name is Fröhling, and they are focusing on small scale, very small scale applications. So I think you can find at our website under the links, the link to company Fröhling, and to ask them for the suggestions.
Okay, great. Specific question, what about Plasco? They had a technology a few years ago. It's a very specific question.
Yeah, I don't know Plasco, sorry.
Okay. Here's a question that you already answered. So many large-scale plants are not in operation anymore. So what's the bottleneck for them? So that's you said, well, it's mostly economic, and they are often demos which are expected to be running economically, but it's difficult to do that.
Yes, I think the economical reason, and if you compare the price of biofuels with the price of fossils, so they are really not comparable at the moment.
Mm-hmm. Yeah, that's another thing. Yeah. Another question here. So, among the various gasification technologies and from a biofuel production perspective, which reactor design looks more promising? So more at the biofuel side of it. From Alexander Garcia.
I think it's not easy to answer this question. It is also depending on the feedstock.
Mm-hmm. That would be, yeah, if there is a focus on woody biomass, what would be the options or versus MSW? So is that like the main distinction?
As I'm from Austria, so I would prefer double fluidized bed gasifier, but it's just my opinion. So if you have an entrained flow gasifier, so it is an option as well. So it is not really, it depends on the situation, on the moisture of feedstock, and also on the scale, how many liters or barrels you would like to produce.
Yeah, how much feedstock can you supply your plant with? What's the quality? For instance, an entrained flow gasifier needs very fine particles, so you need torrefaction before. That's the biofuel development. If you manage to source sufficient feedstock, then you can go very large and develop a route towards Fischer-Tropsch. If you don't have that much feedstock, then I wouldn't suggest an entrained flow gasifier. So it really depends on many topics.
Mm-hmm.
Following question here was, what's your opinion on plasma gasification, specifically for lignocellulosic feedstock instead of MSW or hazardous waste, which is more commonly linked to plasma, but is it also an option to link it with lignocellulosic biomass?
I think in principle everything is possible, but I think plasma gasification has been developed to my knowledge, for hazardous waste, to really dispose of this. It has been developed in Japan under certain conditions where plasma just had a plus because it would deal with your waste the way the law described it. If you go to woody biomass, lignocellulosic feedstock, I wouldn't suggest a plasma because it's an expensive technology and it's not cost efficient. If efficiency is not important, then okay. But yeah, to my opinion, plasma is more for a niche market than really for a larger market.
Anyway, I would like to point it out that the task is at the moment working on the report on this new technology, and it will be published at our website at the beginning with the next year. So if you need more information on this topic, so please go there.
Yeah. Okay, thanks. Good suggestion. I'm scrolling further. I see a question here about fuel and biomass supply agreements from Muktseng Lim. So that's kind of crucial for the financial feasibility of the project. Certainly, if the owners of the biomass supply want to sell it, want to have some profit. And he asks, so how are these smaller scale systems, small scale gasifiers, affected by supply and demand dynamics? Less of a technical question, but I guess the feedstock part, the biomass supply part, is also part of the financial feasibility of gasification projects.
Yeah.
Do you have any comments on
that? No, not so much, but I would say that small-scale gasifiers, they do not use that much fuel, so they can go to different vendors, and then you get market dynamics, which will make it cheaper than when you have to buy from one supplier only.
Yeah, it's also a different topic, I guess. All right, scrolling further. So I think Fabian Schiffer is asking about situation in China where coal gasification is used to produce input into the nitrogen production process. Do you know if any biosyn gas is used for that, or could be used for that?
I think so. He means the ammonia production for fertilizer.
Yeah, I think so.
No, I don't know of any development in this field.
I don't know about the development in this field as well, so I have never heard about that.
But yeah, I think for sure this is one of these possible new outlets in the future for gasification. So.
Yeah, I think the options are indeed wide. I believe that we've covered most of the questions so far.
Yeah, the IEA Finland project, I think there is no information on this. It was announced and that's what it is.
Okay. Okay, Fabian is talking about vertical integration so that the forest owner can be the CHP operator for small scale, so that makes it also much more straightforward to supply your biomass. So that's,
yes, these are in Switzerland. It's pretty common there. So if you are, for example, working wood and you have a lot of your own wood, you have your own gasifier for that.
Mm-hmm. Yeah, and it makes sense when you have a small scale gasifier, so you don't need these huge amounts of biomass in that case. Alright, I see that a few persons are still typing, so let's wait a few for that before we close. So just a reminder, it's been said also in the chat box that so the slides as well as the recordings will be available on the IEA Bioenergy website. I guess it can be very soon, from tomorrow or something. So if you look at the website, you will also find that very soon. See somebody's. Oh, yeah. Is it possible to change feedstock from biomass to plastic waste? So how flexible are gasifiers? You need major upgrades, or what are the challenges?
I think the main challenges are the impurities that you bring in with your new feedstock. So if you have, for instance, a biomass which is low on sulfur and chlorine, and you introduce a plastic waste stream which is high on chlorine and maybe other impurities, then your downstream process is affected by this. If you have a high temperature gasifier, you will produce syngas from both. If you have a medium or low temperature gasifier, you will have a completely different product slate, which will drastically affect what you do with this gas. So there is no, it's not easy. Maybe the gasifier can handle it, but then your even your engine will not be happy about very rich gas if it's designed for biomass.
Yep, it makes sense. There's another from Ismail. He's asking for updates from Andritz Carbona. Pretty specific questions. Do you have something on that? Some information on that? Or?
No, I don't have any information on this.
It's quite specific. All right. One person is typing or not? No. Okay. So I think we covered quite a lot in this. Also covered a lot in the presentation. So really thank you for that. I think it was a very useful overview and also good for everybody here on the line. So thanks again, Berend and Jitka, and I suggest that we close the webinar, and thanks everybody for joining this. So see you next time. Our next webinar will be in March. Let me check the date. It's March 10, and that will be on biochemicals and biorefining. So you will see it appearing also in announcements.
Thank you very much for
Look
listening.
forward
Bye.
to
Thank you for your great presentations today. Let's bring the session to an end. And thank you all for joining us today, and have a great day.